everyone, welcome to the KEAM series Differential Calculus session. Well, today we are going to revise continuity and differentiability and differential equations. Two very important and very easy chapters which can help you score in your KEAM exam very nicely. How? Because these chapters of differential calculate have a lot of weightage. That means lots of questions are going to come from differential calculus itself. Alright. So yes, very warm welcome to all of you. Let's begin today's super awesome class. Now, if you are new on the channel, don't forget to subscribe because in the KEAM series, you will not only get physics, chemistry, maths, complete revision, complete PYQs, complete formula cheat sheet, but you will also get lots of study tips, exam tips, and much more things coming your way before 17th of May. So do subscribe if you want to score 400 plus in each of your exams. All right. So yeah. Good afternoon to all of you and let's begin. Now, today we will be revising continuity and differentiability first and then differential equations. In differential calculus part 2, we will revise application of derivatives and limits because they are also very big chapters. So I didn't want to put much burden on you by doing it at once. So we will do differential limits and derivatives and application of derivatives. These two chapters we will do in part 2. Okay, so you can note it down as well that part 2 we will do limits and we will do AOD. Okay, absolutely Anushri, absolutely. Today I will help you solve each and every type of question that has ever been asked in KEAM exam. So with that much variety of question, do you think you will not be able to solve? Plus we are revising all the formulas. So after watching this session, you don't have to do anything. So differential calculus, these two chapters will be completed. Absolutely. All right. So let's begin the class with the full josh. And if you're enjoying, don't forget to hit the like button and subscribe. Okay, come on. So first we will learn about continuity, then differentiability, then how to find out derivatives of special functions. Okay. Now, what is continuity? So, by the name itself, you can understand that continuity means your graph of the function is continuous. It is not breaking at any point. So, if you choose a certain point and you check immediate neighboring values, you will always find that those two immediate neighboring values where it's like you are approaching it from 0.0001 difference, so that those values are equal. So at that denotes basically your graph is continuous. It is not breaking at any point. Okay. Now, so this is the basis of continuity. Now let's talk about what we have to learn in continuity. So if you have a function and they ask you, check whether it is continuous at x is equal to a or not. So generally from continuity, you will get only this question, nothing else, only one type of question, that a certain function is given fx, you have to check it is continuous or discontinuous. Okay, only this question will come. How you will check? You will check the left hand limit, you will check the right hand limit, and you will find the value of the function at that particular point. And if all the three values are equal, you can say that it is a continuous function. Okay, absolutely Rishan, absolutely. Only by watching this session, your continuity, differentiability and differential equation is completely done. No need to open book after this. That's my guarantee. Each and every formula is there in today's session. My guarantee to you. Okay, so everybody understood how we will check continuity? Now, if you don't know how to find limits, how to apply this concept, don't worry, we are going to practice multiple questions. You also practice with me and you will understand. Fine? Okay, let's move on. Now, why are we finding out limit? Why are we not like just checking the value and tell that, oh, it is continuous or it is not continuous? So basically what happens is, for a particular point, limit basically means you are approaching it for a very near neighbor value. And if the near neighbor values are not equal to the value at that particular point, then that obviously denotes that they are not continuous, because if it's like the difference is 0.000000001, some very minute difference. So if it is a continuous graph, it will almost have same value. Only if it is a not continuous graph, non-continuous graph, only then it will have a break. So that's why we are finding basically limits. Now this is all about concept. We don't have to do anything in the questions related to it. Questions are pretty simple. I'm telling you, they are pretty simple. Okay. Now this was about checking continuity at one point. What if they ask to check continuity in the interval? What if they ask you to check that between point A, point B, my function is continuous or not? So basically you have to check the continuity of function along these 3 points. Okay, you have to check it is continuous in the open interval AB. You have to check it is right continuous at point A, and you have to check it is left continuous at point B. Only then you can say that it is continuous in the interval, closed interval AB. Okay. Now we will do questions, so don't worry that what type of questions will come. Alright. Now, how do we say that the function is discontinuous? If at a particular point you are getting left hand limit and right hand limit not same, then we say that it is a discontinuous function. Okay. Now, discontinuous functions can be made continuous for certain values. For example, here if you see that sin x upon x is like a 0/0 graph. So basically, when I will tell you now in differential calculus part 2, I am going to teach you limits chapter also. In limits chapter, I will teach you L'Hospital's rule. So what happens when there is a 0/0 limit? What do you do at that point? We will learn in limits chapter in detail. So that is basically removable discontinuity. Now they will never ask you question on removable discontinuity. So don't worry about that again. Okay. So continuity is just only one type of question will be asked. It is continuous at this point or discontinuous at this point. Simple. Okay. Next is differentiability. Now differentiability, what is the concept? The concept again says that if your graph is continuous, it will be differentiable. Okay. Next, if you are able to draw tangent at that particular point, your graph is differentiable. If you are not able to draw tangent, if you have a crisp point is like at one exact point your graph is turning. If you have corner points in your graph, then you can directly say that it is non-differentiable. Now generally, how do we find that whether the function is differentiable or not? We find the derivative of the function. From the derivative, we check if the left hand derivative is equal to the right hand derivative. If they are equal, we say it is differentiable. If they are not equal, we say they are not differentiable. Again, if you are getting confused in this, don't worry. We will practice questions today, so you will clearly understand how to approach differentiability questions. Okay. Now, differentiability questions, you will not need to use these formulas in KEAM exam. In board exam, you need these formulas, but in KEAM exam, you have like shortcuts and direct methods to find out differentiability. So we will do those questions, don't worry. Now, there are some graphs and some functions which are directly called as non-differentiable, and one such graph is modulus function graph. Now, modulus function graph is basically we say that it is non-differentiable at the point where it is having a corner, a crisp point. So at that particular point, it is not differentiable. At other points, it is differentiable. Okay. So if it has any sharp point, then the function is called as non-differentiable at that particular point. Now, talking about some standard functions. So you can note down that in which particular interval those functions are differentiable. So when talking about polynomial functions, what is polynomial function? if the power of the variable is a whole number, it is a positive integer or 0, then it is a polynomial function. Polynomial function is always differentiable from minus infinity to infinity. Exponential function always differentiable. Constant function always differentiable. Log function is differentiable only in its domain. Trigonometric function only in its domain. Inverse trigonometry again only in its domain, and modulus function is differentiable only basically between minus infinity to infinity except 0. Okay, so I hope everything is visible to you. Anyways, I will provide you the notes of the lecture. Now, you should know the formula for differentiation of some standard functions. If you don't know the formula, forget about this chapter. You will not be able to solve any question. Okay, so please memorize all the formula. Alright, so along with me, you can also repeat what is the differentiation of constant d by dx of 3. Any number differentiation is 0. What is the differentiation of a variable having a power? The power comes in front and the power reduces by 1. So, differentiation of x square is what? Differentiation of x square is 2 into x to the power 1. Differentiation of x cube is 3 into x square. Clear to everybody? How you differentiate a polynomial function? Now, differentiation of e to the power x is e to the power x, nothing else. Differentiation of a to the power x is a to the power x log a. Please remember. Differentiation of log x is 1 by x. Important. Sin x is cos x. Cos x is minus sin x. Tan x is secant square x. Cot x is minus cosec square x. Secant x differentiation is secant x tan x. Cosec x differentiation is minus cosec x cot x. Okay, this is trigonometric functions differentiation. Next, what if you have a constant multiplied to the function? The constant will be simply multiplied to the differentiation of the function. So what I mean to say is 3 into sin x. What will be the differentiation? It will be 3 into differentiation of sin x. Everybody knows this? Okay. Now some super important formulas. What is the differentiation of fx plus minus gx? It is simply differentiation of fx plus minus differentiation of gx. So nothing happens here. Simply you can differentiate them one by one. But if it is a product, we call it as product rule. When you are multiplying two functions, how do you differentiate? Differentiation of first function into second function. Differentiation of second function into first function. So differentiate this, multiply this, differentiate this, multiply this, and add them at the end. This is called as quotient rule. Quotient rule is basically division of two functions. How do you do it? Denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator whole square. Clear? This is called as quotient rule, used for division of two functions. Next, inverse trigonometric function. What is the differentiation of sine inverse x? 1 upon root over 1 minus x square. Differentiation of tan inverse x. 1 upon 1 plus x square. Differentiation of secant square x. 1 upon mod x root over x square minus 1. Now for cos, multiply minus 1. For cot, multiply minus 1. For cosec, multiply minus 1 in this formula. Okay? Cool. Next is logarithmic function differentiation. Now, where do we use logarithmic differentiation? Now, whenever you see that your y is having a function to the power of another function. For example, if y is sin x to the power, let's say y square. How will you differentiate sin x to the power y square? For this, you apply log on both sides. Log y is log sin x y square. Now remember, whenever your log variable is having a power, that power comes in front. So this will become log y is y square into log sin x. This is super important. Always the power comes in front of log x, comes outside log x. Okay. So this is how we do logarithmic differentiation. So suppose you have an example here, x to the power sin x. Now, what we will do? We will apply log on both the sides. So log y is sin x log x. This sin x will come in front. Now you do the differentiation. So log y differentiation is 1 by y dy by dx. Sin x into log x, product rule. So sin x into log x differentiation plus log x into sin x differentiation. Product rule applied, we got the answer. So this is logarithmic differentiation. Next is parametric function differentiation. This is also asked in KEAM exam. Every topic is asked every year in the KEAM exam. There is no topic which is not asked in the exam. I am only teaching you the topic which are going to short come. So you have to remember and learn each and every topic, please. Now what is parametric form? Suppose x is a function of some other variable. Y is also a function of some other variable. Then how will you find out dy by dx? For this, you find dy by dt, you find dx by dt, and then you divide dy by dt divided by dx by dt. So you will get dy by dx. Okay. So if you divide dy by dt divided by dx by dt, you get dy by dx. So like this we can get dy by dx when x is a function of t, y is a function of t. And not just t. If they are function of theta, if they are function of z, if they are function of 4 square, anything like that. Alright, so these are the concepts which are important for you, and these are the concepts only which are going to come in exam from continuity and differentiability. So we have learnt everything, but now let's apply those concepts. Okay, let's solve the question. So what type of question will come from continuity? In continuity, they will ask, there is a function. The function is 2x when x is less than 1. The function is 5a minus x when the function is greater than 1. They will ask, it is continuous on all the real numbers, on the entire real numbers range. Then what is the value of a? What does that mean? It simply means, if it is a continuous function, okay? If it is a continuous function, left hand limit is equal to right hand limit. Now what is left hand limit? Left hand limit is value of the function for x less than 1. Right hand limit, what is right hand limit? Value of the function for x greater than 1. Okay. Now you just check from here. For x less than 1, it is 2 into x. For x greater than 1, it is 5a minus x. See? Greater than 1, 5a minus x. Now put x is equal to 1. So 2 into 1 is equal to 5a minus 1. It will come here. 2 plus 1 is equal to 5a. So a is equal to 3 by 5. How simple is this question? Are you able to understand how simple is this question? Directly you are getting the value of a and you are getting the answer 3 by 5, right? Okay, awesome. Everybody understood how to check, how to find, how to apply continuity? Okay, next. Sorry, by mistake it is here. Let's come here. Okay. Now you have a function y is equal to tan x to the power sin x. They are asking if dy by dx is equal to this plus gx. What is gx? First, you have to find out dy by dx. How will you find out dy by dx? What did I tell you? Whenever y is f of x to the power of g of x, what do? We do log y is equal to log of f of x to the power g of x. So we apply log on both the sides. How do you apply log on both the sides? Let's check. So it will be log of y is equal to sin x log of tan x. है ना? Sin x is in the power, it will come in front, and then log of tan x will be applied. Okay. Now you differentiate d by dx of log y, d by dx of sin x into log tan x. Okay. What is differentiation of log y? 1 by y into dy by dx, because y differentiation is dy by dx. It is not 1, right? Next, this is what? Product rule. What is product rule? Differentiation of first function into product of second function plus differentiation of second function into product of first function. So you simplify it. 1 by y dy by dx is equal to d by dx of sin x is cos x log tan x plus sin x into log tan x differentiation is 1 upon tan x and tan x differentiation is secant square x. Now you simplify and check what do you get. So till here everybody is clear? Okay. So we have next. I don't have space. Let me just write it over here. Can I write it over here? Wait. Okay. So now this becomes dy by dx is equal to, this y will go to the numerator. So it will become tan x to the power of sin x into cos x log tan x. So till here we have got our answer. Till here we have got the answer. We have multiplied this and we have got the answer. Only now gx is left. So what is gx? So just simplify this. What do you get? So gx is basically equal to sin x upon tan x into secant square x. So tan x is sin upon cos. So sin cancel and cos will go here. Now cos into secant square x is 1 upon cos. So gx is 1 upon cos x. So it is basically secant of x. So your answer is gx function is secant of x. Understood everybody? Okay. So first of all, this is already given in the question. So whatever is remaining is your gx. So from here we get the value of gx. Okay. Now this was logarithmic differentiation. Next, if f of x is this, find f dash of 1. They are asking what is the value of dy by dx at x is equal to 1. So just divide. So dy by dx is equal to 5 into x cube plus sine pi x to the power 4. Now what happened here? We differentiated this. So 5 in front, 5 minus 1, 4. Now you have to differentiate what is inside the bracket. Okay. So you have to do d by dx of x cube plus sine pi x. Differentiate that. So 5 into x cube plus sine pi x to the power 4 into differentiation of x cube is 3x square. Differentiation of sine pi x is cos pi x into pi. Now you put the value. What value? You put x is equal to 1. So you have f dash of 1 as 5 into x cube into sine pi x to the power 5 into 3x square plus pi cos pi x. Okay. So let's put x as 1. So 5 into 1 cube plus sine pi to the power 4. Here is power is 4 into 3 into 1 square plus pi into cos pi. So this is sine pi is 0. So you have 5 into 1 into 3 plus pi cos pi. What is cos pi? Cos pi is minus 1. So please remember, sine pi is 0, cos pi is minus 1. So we'll put here. So we get cos pi minus 1 into pi is minus pi. So we simply get minus pi. So I am getting 5 into 3 minus pi. So that is my answer. 5 into 3 minus pi. Got it? Got it, everybody? Okay, next question. Differentiability. I told you what type of questions will come from differentiability. How you have to solve it, I will tell you now. They are saying that there is a function fx. It is e to the power x when x is less than 1. It is mx plus 6 when x is greater than 1. It is differentiable at x is equal to 1. Then what is the value of m? How you do that? Simply, the left hand derivative is equal to the right hand derivative. What is left hand derivative? F dash x at x less than 1. F dash x at x greater than 1. So less than 1, e to the power x. So d by dx of e to the power x is equal to d by dx of mx plus 6. What is differentiation of e to the power x? E to the power x differentiation is e to the power x. Mx plus 6 differentiation is m. Now m is equal to e to the power x? No, we will put x is equal to 1 also now, because at point 1 we are checking the differentiability. So here we will say that m is equal to e to the power 1. So m is equal to basically e. Now that's your answer. Got it, everybody? The left hand derivative and right hand derivative, how you have to find it? No need to apply the formula f of a plus h minus f of a upon h. No need to do those things. You simply differentiate this and equate them. Put x is equal to 1. Are you able to understand or not how you have to solve differentiability question? Easy, right? It is easy, super easy. We think that it is difficult, but it is not difficult. It is easy. You can easily solve it. Okay, awesome. Let's solve some more PYQs of this chapter. Next, there is a function fx. It is given x plus 2 for less than 1. Between 1 and 3, 4x minus 1, greater than 3, x square plus 4. Then check continuity. How will you check continuity? First, we will check for x equals to 1. At x is equal to 1. Left hand limit is equal to right hand limit. What is left hand limit? Less than 1, x plus 2. Greater than 1, 4x minus 1. Put x is equal to 1. So here 1 plus 2, 4 into 1 minus 1. 1 plus 2 is 3. 4 minus 1 is 3. What do we get? We get left hand limit is equal to right hand limit. So we say continuous at x is equal to 1. Okay. Now, if you look at the options, option number B is function is continuous at x is equal to 1. That is the right answer. You can check for x is equal to 3 also. For less than 3, 4 into 3 minus 1. For greater than 3, 3 square plus 5. 4 3 is 12, 12 minus 1, 11. 3 3 is 9, 9 plus 5, 14. Is 11 equal to 14? No. So, it is not continuous at 3. Simple. 5 and 2 are not continuity points. Why they are not continuity points? Because the function is not changing at 2 and 5. The function is changing at 1 and 3. So we will only check at 1 and 3. Easy or not? Easy or not? Tell me. Easy or not? Easy, right? Okay, awesome. Cool. Next, again, continuity. Function is given for greater than C, for less than C. What is C? Find the value of C. Come on. All of you will solve and tell me the answer. In 30 seconds, your answer should come. What is the value of C? Come on. What is the value of C? Everyone will solve. Everybody should solve this. Let's see who will give the answer first. Whoever gives the answer first will be our MVP today. Most valued player. Come on. Aha, Vignesh. What a nice shortcut. What a nice shortcut. And come on, don't forget to hit the like button and don't forget to subscribe to the channel because we are doing so many amazing things over here for you guys, for your KEAM exam preparation. Every day we are putting out so many awesome videos for physics, maths and chemistry. So do subscribe and don't forget to hit the like button. Done. What happened? So much time, so much time. See. The left hand limit is equal to the right hand limit. So 3x plus 6 is equal to x square minus 3x minus 1. Put x is equal to c. So 3c plus 6 is c square minus 3c minus 1. Put everything on one side. So c square minus 3c minus 3c minus 1 minus 6 is equal to 0. So c square, very good Neha. C square minus 6c minus 7 is equal to 0. Quadratic equation, how we solve it? Just factorize it. So minus 6c can be written as minus 7c plus c minus 7. Simplify it. What do you get? C common, c minus 7. 1 common, c minus 7 equals to 0. So c minus 7 is 0. C plus 1 is 0. This implies C is 7. This implies C is minus 1. Is this your answer? Yes. Option C is the right answer. Minus 1 and 7. Very good, Neha. Only Neha was able to solve it. Why? Why others are not able to solve it? Quadratic equation. Not able to solve quadratic equation. That is not allowed. That is very bad. If you are not able to solve quadratic equation, you will lose so many marks. Tell me, at least tell me, why couldn't you solve the question? Tell me the reason at least. Did you guys understand now how we are getting the answer? Every time confused. Why, Anushri? Where did you get confused? Tell me now. Where did you get confused? At what point? Calculation mistake. Are you guys able to solve quadratic equations? Can you solve quadratic equations? I hope. Okay. Moving on. Now, interesting question. This is parametric form. How do I know this is parametric form? Is my video lagging? Is my video lagging for you guys? I don't know. Is it lagging for you guys? No? Is it fine? The video is fine? My video? Am I audible? I guess now it is fine. Okay. So this is parametric form equation. Why? Because x is a function of theta, y is a function of theta. What do we do in this situation? We simply find dy by d theta and we find dx by d theta and we divide it. Okay. So dy by dx is equal to dy by d theta divided by dx by d theta. So differentiate this with respect to theta. Okay. First, what is square root differentiation? Square root differentiation is 1 by 2 square root. So y differentiation will be square root differentiation 1 by 2 10 to the power sine inverse theta multiplied with differentiation of 10 to the power sine inverse theta. What is 10 to the power sine inverse theta? A to the power x differentiation is a to the power x log a. So 10 to the power sine inverse theta differentiation will be 10 to the power sine inverse theta into log 10 into sine inverse theta differentiation. What is sine inverse theta differentiation? 1 upon root over 1 minus x square. Okay. Now put everything here. So here we will basically do multiplied by 10 to the power sine inverse theta into log of 10 into 1 upon root over 1 minus x square. Now just remove all this. Okay. Now this is divided by dx by d theta. What is dx by d theta? 1 by 2 root over 10 to the power of cos inverse theta into 10 to the power cos inverse theta into log 10 into minus 1 upon root over 1 minus x square, because this is cos inverse theta differentiation. Now you see if anything is getting cancelled. Abhijit, very good, absolutely right answer, very good. Log 10 cancel. This cancel. Then we have 2 cancel. So what is remaining? We get dy by dx is equal to, what is 10 to the power sine inverse theta? It is y square. Y square divided by y. Okay. Divided by, we have x square minus x square divided by x. Okay. Now just cancel. Y cancel. X cancel. So you get minus y by x. This is your answer. This is parametric form equation. For this, you should know how to solve parametric form. You should know a to the power x differentiation. What is the formula we used? A to the power x differentiation is a to the power x log a. This is the formula we have used. All right, understood? Okay, next question. Why is this? Then dy by dx dash. What an easy question. Quickly we can solve it. So dy by dx is d by dx of e to the power 3 log 2x plus 1. So it is e to the power x differentiation, e to the power x. E to the power x differentiation is e to the power x, but multiplied by differentiation of 3 times of log of 2x plus 1. Differentiation of this is 3 into log differentiation is 1 upon x and 2x differentiation is 2. So you get 6 into e to the power 3 log 2x plus 1 upon 2x plus 1. This is your answer. So this will be your answer. 6 into e to the power 3 log 2x plus 1 upon 2x plus 1. I am using chain rule. Chain rule says that keep differentiating. So you differentiated e, then you differentiate log, then you differentiate 2x. Keep differentiating every function you see one after the other and multiply them. Okay, that is chain rule which is used here. Okay. Next, differentiate this and find dy by dx at pi by 2. Let's do that. So, again, product rule. Product rule is differentiation of x multiplied with sine y plus differentiation of sine y multiplied with x plus differentiate this y multiplied with differentiation of sine x plus sin x multiplied with differentiation of y. So dx by dx 1 sin y. Sin y differentiation cos y into x. Then sin x differentiation cos x. So y cos x plus sin x and y differentiation is y only, nothing. Also, wait, here we have differentiated sin y, right? So we will have to multiply here dy by dx. Okay. Now you put x is equal to pi by 2, y is equal to pi by 2. So you have sin pi by 2 plus cos pi by 2 into x into dy by dx plus pi by 2 into cos pi by 2 plus sin pi by 2 is equal to 0, is equal to 0, is equal to 0. Why? Because pi differentiation is 0. Hi Alan. Sin pi by 2, 1. Cos pi by 2, 0. Cos pi by 2, 0. Sin pi by 2, 1. And am I missing somewhere? Dy by dx is missing. Oh, here. Yeah. Here we will, no, not here. Wait. I guess, oh, my bad. I'm so sorry. This is not dy by dy. Very sorry. This is dy by dx, dy by dx, dy by dx, and here dy by dx is equal to 0. So what is the value of dy by dx? Minus 1. Okay. So from this equation we get dy by dx is equal to minus 1. Clear to everybody? So first, just apply product rule, just do the differentiation, put sin pi by 2, cos pi by 2 value and you get the answer. That's it. Okay. Next, this is a very good question. Please listen to it very carefully. It's a very nice, very good question. See what we have to do. Function is given tan x and ax plus b. You have to check. No, you have to basically find the value of a and b when fx is differentiable at x is equal to pi by 4. Whenever you have two variables are given, you have to apply two formulas. What are the two formulas? Please listen very carefully. First formula, what did I say? If the function is differentiable, it is continuous also. So if this function is continuous, what will happen? Left hand limit will be equal to right hand limit. What is left hand limit? Tan pi by 4. What is right hand limit? A into pi by 4 plus b. A into pi by 4 plus b. Because this is less than pi by 4, this is greater than pi by 4. Put the value. What is tan pi by 4? What is tan pi by 4? 1. So we have here a into pi by 4 plus b is equal to 1. This is our equation number 1. Next we have equation number 2. How we will get that? So we know that it is differentiable. So left hand derivative is equal to right hand derivative. What is the differentiation of tan x? What is the differentiation of tan x? Very good, Abhijit. Differentiation of tan x is secant square x. What is the differentiation of ax plus b? Differentiation of ax plus b is a. Then what is secant square pi by 4? Who is gonna tell me what is secant square pi by 4? Quickly. Secant square pi by 4 is, come on, quick. You have to know the trigonometric values. How are you guys not yet remembering trigonometric values? Very good, Neha. Secant square pi by 4 is 2. So what is the value of A? Value of A is 2. Now you have value of A. Find B. What is the value of B? Put it over here. So we have A into pi by 4 plus B is equal to 1. Now A value is 2. 2 into pi by 4 plus B is equal to 1. So 2 cancel. So we have here B is equal to 1 minus pi by 2. So it is basically 2 minus pi by 2. So this is the value of B. So A is 2, B is 2 minus pi by 2. Everybody got the answer? Everybody understood? Okay. Cool. So, I have shown you each and every type of questions that is ever asked in continuity and differentiability. Now you honestly tell me, can you do questions of continuity? Can you do questions of differentiability? Can you do questions of derivatives of log and trigonometric functions? Because in this chapter only these type of questions will come. Continuity, differentiability and derivatives. Okay. Just remember the formulas I have told in today's class. Remember product rule, remember question rule and remember chain rule. If you remember all these things, you are done with the chapter. You know everything from the chapter. Okay. Awesome. Next is differential equations. Very, very easy. Very, very quick chapter. There is a little only in this chapter. Okay. Now, what is differential equation? So, any equation which is made up of derivatives and its higher orders is called a differential equation. Now, what is order of a differential equation? Order means the highest order derivative present becomes the order of the differential equation. So if d square y by dx square is present, it is second order differential equation. If d cube y by dx cube is present, it is third order. Okay. Is this enough? Yes, Albin, it is enough. Next, what is degree of the differential equation? Power of highest order derivative. Which is the highest order derivative here? Quickly tell me. Which is the highest order derivative here? Highest order derivative is d cube by dx cube. What is the power of it? 1. So order of this in differential equation is 3. Degree of this differential equation is 1. It is clear? Order is 3, degree is 1. So do you understand the difference between order and degree? Because in the question paper, they have asked about order and degree in the PYQs, in the previous year question papers. Okay, cool. Now one very important point to note here is, you can only find degree of a differential equation if it is a polynomial differential equation. For example, your differentiation is y is equal to sine of d square y by dx square. What is the order of this equation? 2. What is the degree of this differential equation? Undefined. Why undefined? It is a trigonometric function. It is not a polynomial function. So it is undefined. Similarly, if d square y by dx square is written power 1 by 2, what is the degree? What is the degree? Tell me quickly. Undefined. Degree will be undefined. Why undefined? Because the power should be a whole number. It cannot be fraction. It cannot be trigonometry. The power should be a whole number. It should be a polynomial function. Very good. Okay, now the main topic of this chapter is solution of a differential equation. Now, what is solution of a differential equation? It is basically an algebraic equation which is obtained by integrating the differential equation. So, what we do? We take all the function of y with respect to dy. We take function of x with dx. We integrate it to get function of y and function of x. That becomes solution of the differential equation. Okay, log also, Neha, log also is not defined. Only it should be a polynomial function. Log, tan, exponential, not allowed. It should be a polynomial function. Okay. Alright. Next is, there are three methods for solving any differential equation. Number one, variable separation method, homogeneous differential equation method, and linear differential equation method. Number one is variable separation. Variable separation says that you bring all the function of x with dx, you bring all the functions of y with dy, and you integrate. You integrate it with respect to dx, you integrate it with respect to dy, and add an integration constant. Always remember to add the integration constant, then it will become the general solution. Now, if you know the value of c, suppose you know that c is 2, then it becomes particular solution. If you don't know what is c, general solution. If you know what is c, particular solution. And how to find out particular solution? I will teach you with an example. Don't worry. Next is homogeneous differential equation. How do we understand that it is a homogeneous differential equation? If the power of all functions are same. If the power of all functions are same, it is a homogeneous differential equation. For example, power of x 2, power of y 2. So it's a homogeneous differential equation. Similarly, suppose you have a function, suppose you have f of xy is let's say 2xy minus y square upon 4x square. Is this homogeneous? Yes. Power 2, 1 plus 1, 2. So it is a homogeneous differential equation. Now, how do you convert homogeneous differential equation? How do you solve it? So just divide the equation with x to the power, whatever power you have found. Suppose all of them are having power 2. So divide by x to the power 2, divide by x to the power 2. What is the equation you get? You get 2 into y by x minus y square y by x whole square upon 4. Now what you have to do? You have to put y by x as t. So what do we here do? What do we do here next? We put y by x as t. So y becomes xt and dy by dx becomes t plus x dt by dx. So instead of dy by dx, we put this and then we solve it with respect to x and t. And at the end, we put back all the values. Okay. Alright, so this is what is taught over here, that instead of t, they have taken v, but it is same thing. Then you integrate it with respect to v, integrate it with respect to s, like a variable separation method, and after that you get solution of the differential equation. Okay. Next, and the last is linear differential equation. How do you identify linear differential equation? If you see any equation of the form dy by dx plus p of y is equal to q. Now what is p? P is a function of x. Q is a function of x. For example, sin x, x square, 2x, anything, any function of x. So whenever your differential equation is in this format, we call it as linear differential equation. How do we solve it? So for solving this, we take p and we find out integrating factor. I guess we have taught that. Yeah. We find out integrating factor. In many questions, they have directly asked what is the integrating factor of the question, of the equation. So you have to find out integration factor. How do we find out integration factor? The formula is e to the power integration of p with respect to dx. What is p? The function of x. Integrating it with respect to dx. So e to the power integration of p with respect to dx. After you have found out integration factor, put it in this formula. Y into integration factor is equal to integration of q multiplied with integration factor dx plus c. This is how we solve linear differential equation. Okay. So in this chapter, they will ask you order of the equation, degree of the equation, variable separation method, homogeneous solving method, and linear differential equation. 5 things only. Alright, let's solve some questions. Question number 1. The general solution of this differential equation is dash. Now, first, we always try to apply variable separation. Are we able to separate the variable or not? Okay, so let's try. So it is y minus x into dy by dx is equal to x square plus y square. Let's try separating the variables. So we have, okay, we can do it like this: y minus y square is x square plus x dy by dx, right? Okay. Can we separate the variables? We cannot. Can we send dy by dx here? If I take out dy by dx from this side, nope. And let's check. So, or can we solve it by linear differentiation? No. Can we solve it by homogeneous differential equation? No. Let's try variable separation only. Okay. So how can we put dx here and dy here? So it will become dy by dx minus x square upon x. Even if we do divide by x, we will not be able to solve it. Or can we do it like homogeneous one, x tan x, and it's not linear differential equation. It's not a dx and dy. I guess this has to be multiplied completely. Then it will become y into dy by dx. And are we missing any brackets? Let me see. Are we missing any brackets? No, we are doing it by variable separation. Okay. Okay. We are doing by variable separation only. But the power is not same here. The power is different. Let's do it this way. So we can do it like y minus x square minus y square is equal to x into dy by dx. We divide, so we get y by x, we get minus x, and we get minus y square by x. But this is not homogeneous. This is not homogeneous. The power is not same. Then how are they doing it by homogeneous? Even if we put y by x as t, we will not get. Or maybe we can divide it by x square. Can we divide it by x square? Again, we will get, yeah, we have to divide it by x square. So what we can do is, we can multiply it by x and divide it by x, divided by x, divided by x. So what do we get? We get xy upon x square and 1 and y square by x square. Now we can put y by x as t. So now if we put y by x as t, we get x cancelled, t minus 1 minus, here I have, no, here we will divide it by x, we will get x, here also we will get x, yeah. So we have minus x t square is equal to dy by dx. Now if y by x is t, dy by dx becomes what? It becomes t plus x dt by dx. Now let's transform our equation. So t cancelled. So here we have minus 1 minus xt square is equal to x dt by dx. Now you check, can you separate the variables? So we can do it like x can go that side, or we can take out or we can just divide it by x, divided by x, divided by x, yeah. So we will become like this, minus 1 by x is equal to dt by dx plus t square. Again, this will not be variable separable. Then what are they doing here? Let's see. Where am I? 1 plus v square. And oh, sorry. Y dash is y by x minus y square by x minus x. Yeah, we also got the same thing. Then we have also put it here. Okay, somewhere I am doing a mistake. Let me just cross check it once again. So x and x. Okay. This is x. This is not 1. This is the mistake. So again, all right. So we have here minus x t square. Yeah, that is the mistake. Now we get it, x dt by dx. So I have written here x, but I forgot to bring it down. So I wrote 1, that's why it was not like the variables were not getting separated. But now we can separate it. So now we can separate it like minus x separated. It becomes 1 plus t square equals to x dt by dx. Now x cancel. So we have dt upon 1 plus t square is equal to minus 1 into dx. Now you integrate it with respect to x and integrate this with respect to t. What is 1 upon 1 plus t square integration? So as we know, differentiation of tan x is tan inverse x is 1 upon 1 plus x square. So 1 upon 1 plus x square integration is opposite, tan t. So it becomes tan t is equal to minus x. Minus 1 integration is minus x plus c. Always we will add a constant. Always we will add a constant. So now our equation becomes tan y by x is equal to minus x plus c. So this will be our final solution. Okay. So basically it is not in homogeneous form. So what we did, we tried to convert it into homogeneous form. Okay. Even if the power of the variable is not same, but we have still put y by x as t, and later we try to separate the variables to integrate it. Okay. So always whenever you start from homogeneous, you will at the end have to separate the variables to do the integration. Alright, sorry, we got stuck. But now let's move on to the next question. What is the integrating factor of this differential equation? So first of all, you will have to check, is your equation in the standard form? How do you check standard form? So first, my standard form for linear differential equation is y dash plus p of y is equal to q. Now convert this into standard form. So first is, with y dash nothing should be there, x should not be there. So I will divide it by x. So first is y dash, xy dash divided by x, 2y divided by x minus 7x cube divided by x equals to 0. I will divide the entire equation by x. So here x cancel, we'll have y dash plus 2y, 2 by x into y is equal to x cancel 7x square. Now is this in standard form? Y dash, py is equal to q is equal to q. So now you find out the integrating factor. What is integrating factor? Integrating factor is e to the power integration of p function with respect to dx. So e to the power integration of what is p function? 2 by x. Integration of 2 by x with respect to dx. What is the integration of 1 by x? Integration of 1 by x is? Integration of 1 by x is, anybody remembering integration formula? Log x. So e to the power 2 log x. Now, since whenever we apply log to a function, the power comes in front. So similarly, 2 log x can be written as e to the power log x to the power 2. Because this 2 only has come in front, it can go back to the power also. So it can become e to the power log x square. Now we know that e to the power log is 1, cancelled. So we have x square. So what is our integrating factor? X square. That is the answer. So always remember, if you have e to the power log, e and log gets cancelled and directly the function is your answer. Alright. Okay, awesome. Next question, the general solution of this differential equation is dash. Let's look at the differential equation. Let's see if we can separate the variable or not. If we cannot separate the variable, then we will use homogeneous or linear differential equation. Okay, now first it is given 4xy plus 12x plus 2x square plus 3 dy by dx is equal to 0. So first I can take out 4x common, y plus 3 plus 2x square plus 3 into dy by dx equals to 0. Now put dy by dx on this side, put everything else on the other side. So we have 4x into y plus 3 with minus sign upon 2x square plus 3. Now we can separate the variables. So we'll bring y on one side and x on the other side. So x will go here, y will go here. So we have dy upon y plus 3, okay, and is equal to minus 4x upon 2x square plus 3 into dx, right? Okay. Now what will I do? I will bring this minus sign on the left hand side. Why? Because what is integration of 1 upon y plus 3? So remember, whenever there is integration of 1 upon y, it is always log y. So integration of 1 upon y plus 3 will be log y plus 3. So when you integrate it, log y plus 3 but with minus sign will be there. Now on the right hand side, what will happen? We will use a formula. What is the formula? Integration of f dash x upon f of x is log fx. That means if you differentiate the denominator, you are getting numerator. That means it is that means when you integrate it, you will get log of fx. So here you will get log of 2x square plus 3. Now they are also, basically you also have to add the constant. What is the constant? So we will add log c. Why are we adding log c? Because whenever you are getting log on both the sides, add the constant function also as log, because then only you will be able to apply the formula for log. C can be anything. It can be sin c, log c, cos c. It is just a constant. It can be anything. Okay. Now let's simplify this. So we have minus sign will go to the power. So this will become log of y plus 3 to the power minus 1 is equal to log of 2x square plus 3 into c. Why? Because log a plus log b is log a into b. Remember this formula. So it is 2x square plus c. Now log cancelled. Y plus 3 to the power minus 1 is equal to 2x square plus 3 into a constant. Now basically bring everything on one side. So you will get basically 2x square plus 3 into your y plus 3. Y plus 3 will go to denominator, but because of negative power, it will come back to numerator. So it will be multiplied with y plus 3 is equal to constant c. That is our answer. So this is our function. Okay. Why are they getting multiplied? Because power minus 1 means it is reciprocal. So that's why we'll have 2x square plus 3 into y plus 3. Okay. Now this is a trick that you learned, that whenever you are getting log function on both the sides, apply log c. Write log of the constant. Don't simply write the constant as it is. Okay. Alright, next question. Find the particular solution of this differential equation. What is particular solution? You need the value of constant. Okay. Do you guys want to try this question yourself? Just try this question yourself. Dy by dx is equal to xy square. Ma'am, these questions can we do in a minute? I know they are lengthy, but if you have practiced, then you can do it in a minute. If you have not practiced, definitely not in a minute, because if like you have practiced, you will directly like go log this, log that, add this, add that, put the value. But if you have not practiced, how will you do it so fast? Not possible, right? What method we will use? Quickly tell me which method we will use. Variable separation. Separate the variable, integrate. Separate the variable, integrate. What is 1 by y square integration? y to the power minus 2 integration and x integration. Whenever you have a polynomial function, integration is power plus 1 divided by the power. So integration of y to the power minus 2 is y to the power minus 2 plus 1 divided by minus 2 plus 1. Okay. So what is y to the power minus 2 integration? Anaha, don't worry. Just solve along with me. Integration of this is y to the power minus 1 upon minus 1 is equal to x integration is x square by 2 plus c, a constant. Okay. So we are getting our differential equation as, what is the differential equation we are getting? Minus 1 upon y is equal to x square by 2 plus c. Now how will you get the value of c? They are saying y0 is 1. What is the meaning of this statement? When x is 0, y is equal to 1. When x is 0, y is equal to 1. So put minus 1 upon 1, 0 by 2 plus c. So this is c is equal to minus 1. So you get c is equal to minus 1. So just put it over here. We will remove c and we will write the value of c. So it will be minus 1. So my final equation will become what? Minus 1 upon y is equal to x square by 2 minus 1. Now just look at the options, that which option is matching this. So all the options are given like this. You can simplify it further. So suppose you have coming minus 1 by y is x square by 2 minus 1. Just simplify it. Put y on one side, x on the other side. So here you have, if you take the denominator, minus 1 by y is basically x square minus 2 by 2. Do the reciprocal. As soon as you do the reciprocal, you get minus y is 2 upon x square minus 2. So y will be 2 upon 2 minus x square. Because minus sign will go here, it will change the sign and you will get the answer. Ma'am, why integration of 1 upon y square do not have a constant? Because Nihal, when you are basically finding out solution of a differential equation, then we only put constant on the right hand side with respect to our independent variable. See, x is the independent variable. So only with the independent variable we put the constant value. It basically denotes that some constant can come in integration, because once you integrate a differentiated equation, what happens is, should I explain the logic? See, the logic is, when you differentiate, suppose you are differentiating 2x plus b. So when you differentiate x plus b, what happens? It becomes 1. Differentiation of b is 0. So when you are integrating 1, you get answer as x. But then where is b? Where is your b? Where is your constant? So that's why you add a constant to denote that some constant might have been there when differentiation happened. But now when I am integrating, I don't know what was that constant. So I am just mentioning it as c. Okay. Alright guys. So we have basically done all the questions of continuity and differentiability and differential equation. So guys, these two chapters, please memorize all the differentiation formulas, all the derivative formulas, and then only you will be able to solve the questions. Otherwise, forget. You will not be able to solve any question if you do not solve differentiation, and if you do not learn and memorize differentiation formulas. Okay, that's all for today's class. I hope you guys enjoyed it, and I hope you had fun, and I hope that it was useful for you. If yes, do let us know in the chat box you enjoyed today's session or not. And yeah, did you mark your attendance by hitting on the like button? Yes or no? Yes or no? Come on, hit on the like button and show your Josh. Do subscribe for more such amazing videos coming up this entire week. Till 17th of May, we will have complete KEAM preparation only for you. And lots of tips and tricks also coming your way. So do subscribe. Thank you for watching. See you in the next class. Application of derivative is not over. In part 2, we will do limits and we will do application of derivatives. Both the chapters. Okay. Thank you guys. See you in the next class. Bye-bye. Take care. Bye everyone.